This is the first of several videos on linear systems. In this first one, we're going to learn about classifying. When we classify a linear system, they're either consistent or inconsistent, which means there's either going to be solutions or no solutions. When there's solutions, meaning consistent, the linear system is either dependent or independent. To be dependent, it would be that there's infinitely many solutions. Independent means there's only one. If we were to graph these systems, it means graphically that a dependent, consistent system would be that the equations in the system would all graph the same line. To be a consistent and independent, the graphs of the lines would intersect all in one point. To be inconsistent would mean that when you graph the system, the graphs of the lines do not intersect in one point, meaning they would be parallel lines. So here's four examples where we've got four systems of linear systems, and you're to determine if they are either A, consistent and dependent, or B, consistent and independent, or inconsistent. So here's the first one, and the steps are to do the following. First of all, for each of the equations in the system, solve for y, meaning put it in the slope-intercept form of a line, the y equals mx plus b. First, you'll compare the slopes, and if needed, you'll move on and compare the y-intercepts. If the slopes are not equal, then it's consistent and independent, meaning the equations would be graphed of lines that intersect. If the slopes are equal, then you have to compare the y-intercepts. And if the y-intercepts are also equal, then it's consistent and dependent, meaning they would graph the same line. If they are not equal, then it is an inconsistent system. They're parallel and do not intersect at all. So we're going to take the first equation and we're going to solve for y. And so we would subtract the 15x and then divide by negative 22.5. And we have that y equals 2/3 x plus 4/3. We do the same thing for the second equation. We solve for y. So we're going to add 12 to both sides, and then we're going to divide by 9. And we notice that we get the same exact equation. Both the slope and the y-intercept are equal. And therefore, it's consistent and dependent, meaning they graph the exact same line. In example 2, we're going to follow the same steps. So equation 1, we're going to solve it for y. And we get that y equals negative 4/3 x plus 2/3. Equation 2, we're going to solve for y. And when we simplify, we get that y equals negative 4/3 x minus 2/3. Well, if you notice carefully, they do have the same slopes, but the y-intercepts are not the same. This is positive 2/3, and in this equation, it's negative 2/3. So therefore, they're inconsistent. With the same slopes but different y-intercepts, they're parallel lines. With the system 3, we solve for the first equation. Remember that dividing by 0.5 is dividing by 1/2, which is the same as multiplying by 2. So we get y equals 6x plus 3. When we solve for y in the second equation, we get the exact same equation. So therefore, both the slope and the y-intercepts are equal. It's consistent and dependent. It's the same line. In system number 4, we again solve for y. Actually, equation number 1 is solved for y, but I'm going to turn it around and write it in the other direction. So it's y equals x plus 1. It's just easier that way. And for equation 2, we're going to subtract x, and we get that y equals negative x plus 1. And here we notice that the slopes are not equal, so we don't have to even check the y-intercepts. The fact that the y-intercepts are the same, that's actually just tells us where they intersect, intersect each other. And therefore, these are consistent. This is a consistent and independent system.